All right, welcome, ladies and gentlemen, to Week 10 Open Q&A. I look forward to going through another live stream with you guys where I will go ahead and answer your questions that have been submitted for this week. So on this one, I'm just going to kind of get through right onto my questions. Here we go. So what I want to do is just kind of cover, if this is your first time on one of my live streams, we are going to basically just kind of work through, I think I have like 8 questions that I'm going to go through. And then if I have some extra time, which I'm not sure I'm going to, because I am kind of a little tired today, a little bit more than usual, but I'll try to do my best, see what I can do to stay on for you guys. But we're just going to kind of cover talking about factoring. Some quadratics when a was not equal to 1. We're going to get into just kind of talking about dividing like polynomials into binomials, but I'm going to kind of use the same problem to make some sense of it, which is, yeah, okay. And then we're going to talk about this problem that was submitted to me as far as identifying the value of k. And then we're going to do some law of sines, law of cosines problems. I think I have 3 of them actually that I decided to do. So we'll just kind of go through like when to use what. I do have my calculator, kind of with me, but those problems take a while. So I'm not really I don't really want to go through. I want to show you like how to set it up and kind of like how to prepare for it. But I'm not going to go through kind of everything, or at least like go through finding all the angles. And then we have a solving a exponential that we can go ahead and work on. And then we'll do a problem that I guess a student submitted for something on solving the vertical and horizontal asymptotes. So see, a lot of you guys have add-on to Lemerold. I need help finding the simplest radical form. Akash is deep. More Frank, Chicken Mafia, Adeline, Ellen, Bill Tony, New York Red Bulls. Thanks so much, guys, for joining in. I do appreciate you guys joining with me in on this stream. And this has been my week 10. For those of you that, again, that kind of just joining in, I basically am going to I go live every single Sunday evening here at 9 o'clock Eastern Standard Time, which has kind of been thrown off because I decided to wake up on my new alarm this morning with the daylight savings. So it's kind of spring forward. So I kind of lost an hour of sleep and that's kind of thrown me off like the whole day today, but just kind of like how it is, you kind of get used to it after a day or two. And from there, and obviously since I already kind of lost my, my hour of sleep this morning, hopefully that will help me out for the next day, or at least it won't bother me for the rest of the work. All right. So anyways, guys, if you do have some questions or additional questions, feel free to add them to the chat. If I'm not going to be able to get to them, then obviously, hopefully somebody in the chat can be able to help you out, or at least maybe give you some ideas, some tips, or at least give you a reference to be able to get to them. Actually, because I'll tell you right now, I'm probably not going to get to many of them that I'll be able to do. But I always just recommend, guys, a lot of times at the end, if it is something quick or at least something that I can address for you, then I'll always, try to see what I can do. The other thing, guys, if you do have some questions, I know we are also getting to that portion where we're going to start getting exams are going to be coming up. So, last year I did a pre-calculus exam. And then this year I'm looking into doing a algebra 2. Last year I did a pre-calculus review for the exam. So I will make sure that I kind of refresh that and repurpose it to go ahead and show you guys again for this year, or at least just make sure I have that something new on there and then, or on my channel. And then this year I'm going to plan on doing a algebra 2 review. So for any of you guys that are in algebra 2 or college algebra and doing a lot of those types of problems, hopefully that will help you guys out. All right. And if you guys are taking some other classes, I apologize. I do have pre-calculus and algebra 2. Eventually hopefully I'll be able to get into something like for the AP calculus beyond there. And then, maybe in algebra 1 or geometry, just kind of depends on how much time I have, which at this moment is not very much, but hopefully we'll be able to continue, just keep on building up more and more reviews every single year. All right. So let's go ahead and get started with these questions. And then, the other thing I wanted to mention too, guys, if you do have questions, feel free every Saturday, I go ahead and post on my community tab where you guys can go ahead and submit questions just to remind you of our live stream. So therefore, when you do have questions, whatever you are reviewing or going over in your class, feel free to always submit them. I can't answer every question, but sometimes I'll be able to answer them in the chat or on the live stream, or just let you know that either I won't be able to cover it or I might need some more time to go and work through them. All right, so let's go ahead and get started. So the first one is factoring when a is not equal to 1. So I told students I would work through this a couple different ways, and I know there's kind of more of a very, a popular kind of post is like a new way of like solving quadratics that I remember looking at, and I didn't kind of cover, didn't have time to kind of cover it, be going through this, but I want to kind of discuss like two different ways to think about this problem. And because one of the things that I think comes up a lot in Algebra 2 is a lot of students will learn like how to do it the one way. And then when we get to like pre-calculus or higher above, students like they can only refer to like that one short way, and they don't really, it takes them too long to understand things. So what I'm going to do is I'm going to explain it kind of the way that I was taught, but that's not really the reason why I'm teaching it, just because I was taught it that way. It's really just for the simplicity of really understanding what's going on. And then I'll go through a longer form version, which is very helpful in case you get stuck trying to factor a quadratic, because a lot of times not every quadratic is going to be factorable. So you want to make sure you have a technique and a method that you can follow to be able to see if it's going to be factorable across real rational numbers. So first thing, when we want to factor a quadratic, we know that we can factor it as a product of two binomials. So what I'm going to do is I'm just going to break this down into two binomials here. So remember, when you're factoring or when you're multiplying two binomials, the first two terms are going to give you this first term, 2x squared. So assuming that everything is going to be in integers here, we can say that's going to be 2x and 2x. Now the last two numbers have to multiply, or the last two numbers that I multiply in these two binomials is going to give me a -3. So again, I really only have two options. I have -3 and +1, or +1 and -3. Now again, just with a little bit of thinking ahead, I can see that if I multiply 2x times 3, that's going to give me a 6x, right? And then if I subtract 1, that's going to give me a 5x. And that's exactly what I'm going to need. So again, like this method, I remember my teacher, like it would, it'd always be like, how are you understand? Like, how are you seeing these so quickly? And again, it really comes down to a lot of practice. Like even in my class with pre-calculus, I give my students a ton of these types of problems. Very simple, only when 2x and 3x are the coefficients. But again, it's just that repetition and that practice, you start to see these patterns a lot quicker and easier. And again, if you were to always multiply this out, oh, crap. I totally forgot. Hold on a second. I was going so quick that I forgot to put in my Ethernet cord. So therefore, I was going off of my Wi-Fi, which is not really ideal. So I do apologize for that if you guys were getting some drops on my live on the stream. So let's go ahead and try to connect it from there. Let me see if this ends up being a little bit better. So hold on, there might be a little issue, but we'll kind of see how this goes. I think we're good. All right, so I'm just going to go ahead and continue on, and we'll just kind of go from there. All right, so I don't even remember what I was talking about. The inner and the outer, when you're like multiplying these, needs to be positive. That's why you want 2x times +3 to give you a 6x, and then this would give you a -1. That's going to add to give you a +5x. If this was a -5x, then you'd want that to be a -3 and that to be a +1. In the same regard, in the same case, like what if we only wanted a difference of 1? Well, then the 1 and the 3 would need to be switched, right? Because if you multiply 2 times 1, that'd give you like a +2x, and this would give you a -3x if that was a -3. So you can see how that would give you a difference of 1. But again, those are your really only two options that you have. Now, let's say everything that I just said to you was very, very confusing and you're not at that stage at all. So one of the other techniques we can use, which I haven't even done in a very, very long time, is using what we call like the AC method. So what you can do in this case is just multiply 2 times -3 to give you a -6. And again, you can use kind of sometimes these little diagrams to kind of understand what we're looking for. And then in this case, we can take the middle term, which is going to be 5. Now what we're doing is looking for what two numbers multiply to give you a -6, but then add to give you a +5. Well, in this case, you can see a +6 and a -1, right? 6 times -1 is -6. 6 plus -1 is going to be 5. So now what I'm going to do is I'm just going to break up a 5x into a 2x squared plus 6x minus x minus 3. Now, again, a lot of students like have confusion with this, and sometimes also you could do the box method, which is another way of looking at that, like thinking about area, which works as well. But again, I'm not going to, well, I guess you could. 2x squared plus 6x minus x minus 3. So you can kind of do the same thing. And then what you're doing is now by factoring out, you're kind of looking for these side lengths here. But again, I don't want to get to too many different techniques here. But basically by reorganizing everything this way, now what you can do is kind of factor by grouping and factor out their common terms, which in this case, you can see that these share a 2x, and that's going to leave you with an x plus 3. And here they share a -1, and that's going to leave you with an x plus 3. And then you can factor out the x plus 3, and you can see you're going to get this exact same answer, 2x minus 1. Now, this works great because it's going to give you the same answer, and you can just follow the steps. But as far as like understanding like why you want to do this to this, why the grouping, I think just creates more confusion, and students just don't really remember it or really understand it. So that's why I kind of lean to this method as far as understanding the patterns and understanding the technique as far as what we're looking for, right? When we're looking for factoring, we're looking for this to be broken down into a product of two factors. This is great to follow step by step to understand it, but I also feel like a lot of students don't really make that connection with there. Now, again, I've spent way too much time on one problem, but again, it's something important. I think it's very important for, a lot of students have a lot of trouble with factoring. And I think that's because a lot of times we've avoided like really the understanding of factoring and just kind of focus on giving students all these difficult factoring problems where they have to follow this step-by-step method. And then they don't really get the understanding of what they're doing and why they're doing it. And then they just memorize these steps and then forget them, the next week. All right, so then let's kind of go into like dividing. So, how does understanding dividing? So my key point here, I wanted to just kind of do a couple techniques. So let's say I had 2x squared plus 5x minus 3 all over x plus 3. Now, we could already simplify this, right? So one thing I already showed you is if you go ahead and factor 2x minus 1 or factor the numerator, oops. And I know I'm kind of doing a little cop-out here as far as an easy problem, one that I've already know the answer to. But again, I think this is really important for you to see. So if I wanted to divide x plus 3 into this polynomial, well, the first and easiest way to do this would just to look into factoring the numerator. And by factoring the numerator, I can see that the x plus 3's divide out, and that just leaves me with 2x minus 1. Now, again, that's when it's easy, right? Majority of the time, we can't factor the polynomial, or at least we don't know what the factored form would be. So therefore, a couple different ways. One is we can focus on long division. So by using long division, all we're simply going to do is just take our divisor and we're going to divide it into, our dividend, which is our numerator, 2x squared plus 5x minus 3. Okay, so x goes into 2x squared. And again, if you're getting confused with this, how many times does x divide into 2x squared? Well, that's going to divide into there 2x times. And then now we're going to take that 2x and we're going to multiply it by both terms of your divisor. So you have 2x times x, which is 2x squared, and then 2x times 3, which is a positive 6x. Now, it's very important when you're subtracting here, you subtract the rows. Now, again, you're subtracting everything. Notice how I use parentheses, 2x squared minus 2x squared, and then it's going to be 5 5x minus 6x. So that's going to give me a negative x. That goes to 0. X divides into negative x, negative 1 times. Now you multiply the negative 1 times both terms. So that becomes a negative x, and that becomes a negative 3. And when you subtract these rows, you can bring down this negative 3. You're going to get 0 as a remainder. And again, that was the answer we already knew. Now, the last technique that becomes a little easier for a lot of students because they have trouble with the long division. Now, it's really important. It's really helpful actually to remember. I think factoring is the easiest thing to do. So doing factoring is the best. Then long division is also going to be like a good for sure method to always do it, always get the correct quotient. However, a lot of students will make mistakes. They do not like long division, so they always want to rely on synthetic division, which is the next technique. However, I would just caution you when you're relying on synthetic division, you can only use synthetic division when your divisor is going to be linear. So therefore it has to be like x to the first power. You don't want to use quadratics or cubics or anything else. And then also you want to make sure you have a coefficient of 1, because when the coefficient is not 1, then you have to take into consideration that when you do it. And I'm not going to get into the full scope of this, but that does just kind of create a little issue for the synthetic division part. Now, when you're doing synthetic division, we're not going to use actually the factor, but we're going to use the 0. So what we do is we'd set x plus 3 equal to 0, and then we did x equals negative 3. So for synthetic division, what you do is you take the 0, which in this case is negative 3, and then you're going to take the coefficients of your dividend. So 5, 2, 5, and negative 3. And if you didn't have like an x here, you'd use 0 as the coefficient. Now again, we're going to bring down the 2. So you always bring down the first term, and then you multiply on the diagonals, add on the verticals. 2 times negative 3 is a negative 6. 5 plus negative 6 is negative 1. Negative 1 times negative 3 is a positive 3. Negative 3 plus 3 is 0. Now, again, the confusing part is, we like factoring because that just left us our answer. Long division, what's above here is going to be our answer. Synthetic division gives us this. So we have to kind of interpret what we're given here. So the last number here is going to be your remainder. This is your constant, and this is the coefficient of your linear term. So again, we can now rewrite our answer as 2x minus 1. So that is just kind of 3 different ways to kind of think about that. As far as dividing polynomials, typically factoring is going to be the easiest, but most of the problems you're not going to be used factoring because they're going to be ones that are a little bit more difficult. So therefore, relying on long division or synthetic division is going to be what you're going to want to do. All right, for the next question, the student was trying to find the value of x, and now the one important thing is this equation has 2 real roots, and they want us to find k using the discriminant. And one of the questions the student had was why was it greater than or less than, not less than or equal to, something like that. So, so the first thing is if we want to solve for k, and I think they said something about using the discriminant. So again, remember the discriminant is b squared minus 4 times a times c. Okay, that's the discriminant. And that's basically a great way to be able to identify the types of solutions that you are going to have. So if your discriminant is going to be less than 0, you're going to have no real solutions. If your discriminant is going to be equal to 0, then you're going to have 1 real solution. Okay, and then obviously if your discriminant is going to be greater than 1, then you're going to have 2 real solutions. If your discriminant is a square number like 4, 9, 16, 25, 36, 49, then you're going to have integer solutions. And if it's not, it's like 10 or 11, then you are going to have irrational solutions. So, and again, remember this comes from the quadratic formula, x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So you can see where this discriminant comes from. That's basically what you're taking the square root of. So what I'm going to do is I'm just going to take the discriminant of this equation. So I'm going to have negative 2 squared minus 4 times k. And basically I want to see what does this, equal here. So let's just equal it to 0 to be able to see what is what is my discriminant basically going to equal? So in this case, I get 4 minus 16 equals, okay. And then, what am I doing? Okay. And then you can say basically K, you subtract the 4 divided by 16, K equals 1/4. Now again, if K was going to be, oh, I'm sorry. What am I doing? I was like, why was this equal to that? We want this to be greater than or equal to 0. We don't want this to equal 0. Well, it could equal 0, but we want this to be greater than or equal to 0, right? Because again, the discriminant, is going to be, we want the discriminant to be b squared minus 4 times a times c is greater than or equal, is greater than 0. That's going to be 2 real solutions. Okay. So, or 2 real roots. And again, that was our case here. We had 2 real roots. So that's why I did greater than 0, not greater than or equal to. So sorry, I kind of got ahead of myself. So you're going to set that greater than 0, and therefore that's why it was, actually it's less than. I got to slow down. Let's just show our work. So first thing you're going to do is subtract a 4. Then you have a negative 16. K is greater than negative 4. When you divide by negative 16, remember that's why you flip the sign, right? Good old solving for inequalities. That's why it gets flipped, and that's why it's 1/4. So K needs to be less than 1/4. But again, that less than is because that is what we're looking for when we have 2 real roots or 2 real solutions. If it was 1 real solution, we'd set it equal to 0. And if it was no real solutions, we'd set it less than 0. All right. The next example is like how to solve the, how to use the law of cosines when you have 3 sides. So what I'm going to do is I'm just going to kind of set up the equation. And then basically, guys, I mean, depending on your calculator, you can just type everything in. Sometimes people are going to have issues, with it as in a calculator. But I think, as far as just typing everything in step by step, you should be fine. Now, there is, when you have side though, I think it is very, very important for you guys to understand like which angle to solve for first. And when you have side, you always want to solve for the angle that's going to be the largest. And obviously the largest angle is going to be the angle that has the largest opposing side, right? Since 10 is the largest side, that means B is going to be the largest angle. So that's going to be the angle I'm going to want to solve for first. And again, what's nice about this is if I can solve for that angle first, that is going to that angle could be obtuse or it cannot be obtuse. But either way, after I've found the largest angle, I don't need to worry about the ambiguous case for the law of sines, because remember the ambiguous case of law of sines is we don't know if the angle is acute or obtuse. So your calculator always gives you the acute angle, but you have to check for it to be obtuse. Well, if you're using the law of sines, or law of cosines, and you find the largest angle first, you don't need to worry about there being any other angle that's going to be larger than that. So every other angle after that is going to be acute. So that's the nice thing about this. Now, again, typically when we're doing the law of cosines, one thing that's nice is if you do the law of cosines once, just continue using the law of cosines and you never have to worry about making a mistake with the ambiguous case. However, in this is the one situation that when you have side and you have found the largest angle, you can go ahead and revert to the law of sines just to go ahead and solve the remaining angles of the triangle. So let's go ahead and set that up. Now, if I did have cosine of B, then if I was going to go ahead and solve this, now again, guys, I do not have the law of cosines in front of me. So I believe if I was going to set this up, cosine of B, that'd be a squared plus c squared minus b squared all over 2 times a times c. Okay. And again, I'm just going off of memory from teaching it from, just a couple weeks ago. So, but that'd be the formula. And then again, you're just going to be solving for this b. So b is basically going to be the cosine inverse, right? Because again, if you want to solve for b, you got to use the cosine inverse of that. So just make sure that a lot of students, they're like, oh, my angle is like 0.10. I'm like, no, you got to use the cosine inverse. And then I'm just going to have a squared, so it'd be 6 squared plus 5 minus 10 squared all over. Now, again, when I'm typing this into my calculator, make sure you use parentheses. That is probably the most common mistake that I see students use is they'll type this all into their calculator and they won't put the denominator in parentheses. So that's really the big mistake I would see. And again, the way to avoid that would be to evaluate the numerator, evaluate the denominator, divide them separately, and then take the cosine inverse of that answer. But if you are one of those people that like to type everything into the calculator, just make sure you're using parentheses. And again, you got to make sure you're putting that denominator in parentheses. And I don't know what the answer is. I didn't calculate it. I actually just made up these problems. But hopefully at least that gets you set up there. Now, this next example, you can see this is a angle side side. Now, so we don't have enough information to use the law of cosine. So that means we have to rely on the law of sines. And basically the idea of using the law of sines is when we have a ratio here, when we have a angle and its opposing side length. Now this one actually I meant to go ahead and check, even though I kind of have a good idea that this is going to be, yeah, okay. So, a couple things is when we have the angle side side, obviously, bad word, right? That means it's not going to be enough information for us to be able to determine if we have the ambiguous case or not. So, I'm sorry, if this is the correct triangle, if it's an acute or an obtuse triangle. And again, the reason why that works is, not to go too much into this. But again, if that angle's fixed and that side length's fixed and that side length's fixed, well, we don't know which of these angles. Like that angle could look like that, or it could look like that, right? So that's the problem with the angle side side is you don't know, does it look like this or does it look like that? Is it an acute triangle or is it going to be an obtuse triangle? So in this case, we don't have enough information. So the best way that I kind of taught in my class is to find the height. Now the height is going to be 6 times the sine of 42 degrees. So it's always going to be this adjacent side or this included side times the angle. And when I typed that into my calculator, I got 4.014. Now, as long as my opposite side, which is opposite of the angle, as long as that is larger than the height, a triangle exists. If that's shorter than the height, then no triangle would exist. And as long as this number 7 is going to be larger than the height as well as larger than this included side here, then therefore I'm going to have one triangle. So I'm not going to have to worry about the ambiguous case. However, let's just pretend that this side length was 5. So if this side length was 5, it's larger than the height, so a triangle exists, but it's shorter than this side length. Therefore, we'd have the two cases, and therefore we'd say two triangles would exist. We wouldn't have enough information to know which triangle we need to solve for. So therefore, we need to solve for both. So again, I have obviously a ton of videos on identifying the ambiguous case. I just want to kind of review that though real quickly for you. In this case, what we could do though is just go ahead and solve for angle C. So again, the law of sines would be sine of C all over 6 is equal to the sine of 42 degrees all over 7. Now, in this case, notice how I put the C in the numerator. And a lot of times students are like, when do you put, because sometimes also we have like the law of sines where the side lengths are on the numerator. And again, my idea I tell students is basically you always want to solve for whatever the variable is, you're going to put that in the numerator, right? So since we're trying to solve for C, then again, that's what you're going to be in your numerator. So that's why I have the ratio in my numerator. And then again, if you just kind of multiply the 6, C is going to be the sine inverse of 6 times the sine of 42 degrees divided by 7. And then you can go and solve there. And then just remember B is going to be 180 degrees minus A minus C. So you go ahead and figure out what C is, and then you can go ahead and subtract from 180. And then you could also go ahead and use the law of sines one more time to go ahead and find B. So once you find B, then again, you could use the law of sines one more time. Just make sure you put the side length or b, little b in the numerator that time. All right, for the last example, just another one when we had side angle side. This is using the law of cosines. Now again, this one, we don't have a ratio, so we can't use the law of sines. So in this case, we need to solve for our side length. And so this one's a little bit easier. A lot of students like kind of solving for the side length rather than the angles. The important thing is here, now obviously we have an obtuse triangle, so we don't have to worry again about the ambiguous case. However, it is important, I think, in this example to just kind of always get used to, like, and again, kind of goes back to my first example, like when you're using the law of cosines, just continue using the law of cosines. Like, yeah, since you have an obtuse triangle, you can now use the law of sines to be able to find the missing angles. And that's fine. But again, if this wasn't obtuse, then what you're going to want to do is make sure you stay with law of cosines, because you do not have enough information to confirm that that is going to be the largest angle. So the only reason why now we could use the law of sines is because that's an obtuse triangle. So we know that's the largest angle. However, if it's not obtuse, then you don't have enough information to confirm that. So therefore, you'd have to use law of cosines twice. And again, this formula, just a review, would be a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. So we'd have a equals the square root of 4 squared plus 5 squared minus 2 times 5 times 4 times the cosine of 115 degrees. And again, you could just plug that all in to your calculator and to be able to solve that. And then, again, from here, then you can go ahead and use the law of sines. But again, if this wasn't obtuse, then you'd want to use the law of cosines. All right, next example is a logarithmic. And again, nice thing with the logarithmic, basically two ideas. You basically want to look into using the change of base formula, or in this case, you want to take the log to get rid of our denominator. Because again, if we need to solve for x, we got to get x off the powers, right? Outside of the powers. So again, sometimes it's not looking the change of base, but the one-to-one property. So we can either rewrite these as the same base, so therefore we can apply the one-to-one property, or we're going to want to look into using logarithms on both sides to be able to get our x's off the denominator. So I'm not going to solve this all the way through just for the sake of time, but I will at least set this up. If I wanted to, get rid of these, if I just took the log, and again, let's just take the log of base 15. And typically you just want to pick one of these bases. It doesn't really matter which one you choose. But if I took the log base 15, now what's nice about this is obviously this goes to 1, so you're just left with 2x plus 3 using the rules of logarithms. Here, you can again use the rule of logarithms now to get x minus 4 times log base 15 of 11. So the thing what you're going to want to do now is use your calculator. Typically, if you don't have a calculator, you can involve that. Then you could use the change of base formula. So you could use the, either the natural log, or you could use base 10 log, and then figure out what that value is. And then basically now you can just distribute whatever that value is to both of those, and then to go ahead and solve for x. So then get the x to the same side and then go from there. But again, that's just going to be dealing with a whole bunch of decimals, and it's going to take a little bit longer, but hopefully at least I understand how to get the x's off from the exponents as far as the powers. And then it's just going to be dealing with using some decimals. All right, the last example, guys, that I had at least prepared, and then I will check in with the chat because I haven't really gotten to the chat since the beginning. It's just talking about the vertical and horizontal asymptotes. So kind of going back to our original problem, which is a good idea. What was that problem? 2x squared plus 5x minus 3. Okay, so I have 2x squared plus 5x minus 3. Okay, so let's go ahead and identify, let's just say if this was x what was it? 2x plus 3. So let's just do x, I don't know. There we go, plus 7. Okay, so in this case, to find the, what was it? Hold on a second. I just forgot my brain hurts. X plus 3 to x minus 1. Okay, x plus 3, I'll just do that. Okay, so in the first example, if I had this, so if I had an example like this, and I said find the vertical and horizontal asymptotes, the first thing we want to do is find the vertical asymptotes, and that's going to be the values that's going to make the denominator equal to 0. However, we want to make sure that that value is not going to be divisible into that. So we want to make sure we can factor that, right? Now, again, we already know our answer here. So we know that x plus 7 does not divide evenly into our numerator. So therefore, we can say that when x plus 7 is equal to 0, that's going to be a discontinuity. It's not going to be removable because it cannot be divided out. And therefore, it's going to be a vertical asymptote. Okay? If it does divide into it, then it would be a whole, which we'll talk about in a second. But anyways, we're going to have x equals -7 is our vertical asymptote. Our horizontal asymptote, whenever the degree in the denominator evenly divides into our numerator, then we're going to have no horizontal asymptote. So when our degree in our denominator is smaller than our degree in our numerator, then we're going to have no horizontal asymptote, and therefore I'd either want to look for holes or for slant asymptotes. Now in the next example, let's say I had 2x squared plus 5x minus 3 divided by x squared plus 3x. Okay, now again, in this example, I'm going to want to simplify this. So I already know my answer in the numerator, 2x squared times x plus 3, all over x times x plus 3. Now in this case, you can see that x plus 3 divides into it, right? So even though x plus 3 is or x equals -3 is a discontinuity, like that makes the denominator equal to 0, it's a whole. So I can say at x equals -3 is not a vertical asymptote. That is a whole. However, x is still in the denominator. So when x equals 0, that is going to be my vertical asymptote. So again, that's the idea of the removable that can be divided out or the non-removable discontinuity. The other thing that's interesting is my degrees, the degree in the numerator and denominator are the same. So when the degree in the numerator and denominator are the same, then my horizontal asymptote is going to be the leading coefficient 2 of the numerator over the leading coefficient of the denominator 1. So that's going to be y equals 2 over 1, which is just 2. All right. And then the last example is, so I guess I do my examples like this. Okay. Last example is, what if I had 2x squared plus 5x minus 3 all over x cubed? Oh, here, let's just do, no, why don't I do this? Why don't I do a 2x minus 1? No, sorry, I'm an idiot. What am I trying to do? Let's just do what I was originally going to do. Let's just do x cubed. So again, we notice that nothing's going to divide out this x cubed, right? You could factor this out, but like nothing's going to divide out. But again, it's still kind of helpful to like look at it that way. Okay. So again, nothing divides out like it did up here. So therefore my vertical asymptote in this case is going to be at x equals 0, right? Because when x is equal to 0, that makes the denominator 0. So therefore the value is undefined. As far as horizontal asymptotes, again, we're going to be looking at the degrees. Since in this case, the degree in my denominator is larger than the degree in my numerator, my horizontal asymptote is going to be y is equal to 0. So to kind of summarize, when you're looking to identify the vertical asymptotes, you basically just want to set the denominator, equal to 0 and solve. You just want to make sure that your denominator or whatever factors you have does not evenly divide into this numerator, because then that's going to be a whole, a removable discontinuity rather than a non-removable or asymptote. As far as the vertical or horizontal asymptotes go, you're basically just going to be comparing the degrees. Either degree in the numerator is going to be larger than the degree in the denominator, therefore those no horizontal asymptote, or the degree in the numerator is going to be equal to degree in the denominator, where therefore the horizontal asymptote is the leading coefficient over the leading coefficient. Or in the last example, the degree in the numerator is going to be smaller than degree in the denominator, so therefore a horizontal asymptote is at y is equal to 0. Whew. There you go, ladies and gentlemen. Awesome. All right. I don't know how much more I really have back into me, but I do see Ajay, Adeline, Gabriel, Natalia. Good to see you guys. Kankan. That's awesome. Good for you, man. My functions grade from 1170 to a 90. That's awesome. Good to hear. SP1. Hi, Jessica. You are very welcome. Glad you are killing it on your trig. That is sweet. And thank you so much, other Jessica as well, for chiming in. Adeline goes on you an apple. Thank you. I appreciate it. Awesome, Justin. I hope my explanation helped you out. Hi, Rodrigo. Good to see you guys joining in. Thank you guys so much. All right, so geometric sequence. It's been a while since I talked about the geometric sequence. Noni asks, how do you graph f of x equals x squared minus 3? That's something I can easily kind of talk about. Maybe I'll pick one more. F of x equals x squared minus 3. How do you graph that? Well, again, I mean, a couple things. You could use a table, obviously, but hopefully you guys recognize that there is the graph x squared, right? So if you're subtracting the 3 outside of the function, that's just going to shift the graph down 3 units. So it's really just understanding those transformations, I think, is going to be the easiest and fastest way. Again, understanding those relationship, right? If you have x squared, like when x is 1, 1 squared is 1. When you have 2, like x squared is 4. So it's like over 1, up 1, over 2, up 4. And again, because think about negative 1, like negative 1 squared is positive 1, negative 2 squared is positive 4. So you can just follow that relationship if you needed something that's a little bit more accurate than just the sketch that I'm doing. But again, I'm just going to take this graph and just shift it down 3 units. And I guess you could find the, and then another way too, also you could find the intercepts. Remember, it's just replace f of x equal to 0, right? And if you put f of x equal to 0, you would add the 3, take the square root. So these x intercepts occur at plus or minus the square root of 3, which is not very nice. So that's why I probably would assume that you just have a rough sketch there. All right. Thank you. Well, you're very welcome, Sabrina. Happy to help. Can you have an example of a vertex, like for a quadratic? Because again, there's a couple different ways you can look at this as far as vertex form. All right, so you wanted that. 6x. My question is 4x plus 2, 6x squared. I need to multiply it. Okay, well, I can go over that, I guess. I won. 10. So you had 6x squared times 4x plus 2. So I guess you didn't want the vertex, you wanted that. Well, Juan, if you can throw in your questions really, really quickly, I'll see what I can do. But I'm probably going to cover this question and maybe yours, depending on how simple and easy you can make it for me. So either way, let's go ahead and just cover this. Again, remember guys, like, you know, basically the thing here is like the, I don't even think the distributive property, like if you have A times B times C, you got to multiply those times 2. So this would be AB plus AC. Now, the other thing we need to remember is the rules of exponents. Like if I have x times x times x, well, that's really x times the first to x to the first. That's really just x to the 1 plus 1 plus 1, which equals x cubed, right? You can see that x is being multiplied by itself 3 times. All right, so in this case, I need to multiply the 6x squared times both of these terms. Now, when you are multiplying these terms, you are going to be multiplying the coefficients. So therefore, this is going to be a 24x cubed, and then plus, because again, that's going to be 2 times the 1. Again, you're adding the powers, right? And then here you can just multiply the 6 times the 2, which is going to be a 12x squared. So I didn't really do a very in-depth description, but hopefully that at least kind of helps you out. And Chelsea, you did want to find the vertex. All right, I did say I would probably do that, but geez, okay. What is the maximum value of that? All right, Juan, I can kind of help. I'm not going to do the maximum value because that's not very nice numbers, but that kind of goes right into Chelsea. So I think that's a great idea for me to kind of talk about and to finish off this stream with. So is that plus a negative 60x? So I'll just do a minus 60x, I assume. Minus 600. And then Chelsea gave me a problem of f of x equals 2x squared plus 4x minus 1. Okay, and I see, Mike, that you have a question. Can we give the answer that is in both factored form? And it really depends, Mike, on your test, what the test, how the question is phrased, or what your teacher is expecting from you. And the hand said, how do you graph that? Just use transformations. That's shifting to the right 2 and down 5. Sorry, that's just trying to help you guys out as much as I can from there. Okay, so let's just kind of talk about these two problems, because let's just say this one is y. Because to find the vertex, we're not going to use the same process. We could, but we're probably not going to want to. So this is, we could think about this in ax squared plus bx plus c. So we're going to keep this form. And then this one, you could do it that way, but I would probably prefer to write this in vertex form. Okay, so if it's in vertex, the vertex here is going to be h comma k. When you're in standard form, the vertex is going to be opposite of b divided by 2a, comma, y sub or f of opposite of b divided by 2 times a. So this kind of looks a little bit confusing. That's why knowing the vertex form is important. But basically, if you remember, opposite of b divided by 2a is the line of symmetry, right? So again, like look at any parabola that you have. Like any parabola, it looks like this or it looks like that. That vertex, that maximum or minimum is always going to lie on the axis of symmetry. So again, that axis of symmetry is opposite of b divided by 2 times a. Or you can think of the vertex as just your h comma k. So you can see that it doesn't matter, like, however you want to think about it. You can think about it as hk if it's in this form, or you can think about it as opposite of b divided by 2a is the x coordinate, and the y coordinate is when you plug that value in. So in this problem, I would not want to try to complete the square to write this in vertex form. All I would do is take 60 and divide it by 2 times a negative 1.5, or opposite of b, sorry, so positive 60. And then I'd figure out what that value is. Then I would plug that answer in. So again, what is that going to equal? Actually, we can figure that out, because that's going to be a negative 3, right? So 60 divided by negative 3 is going to be what? A negative 20. Then you could just plug in a negative 20 into that equation. And again, I'm not going to plug that in, but whatever that answer is, that's going to be your y coordinate. So it's going to be negative 20, comma, y is negative 20. So whatever that answer is. Now, this student could do the exact same thing. You could take negative, they could do the opposite of b divided by 2 times a. Perfectly fine. However, it's really helpful to just be able to understand how to complete the square. So I'm just going to kind of run through this just real quick, just to kind of practice, because I think almost every live stream, people always ask me for completing the square. So if you've missed a completing the square, then maybe this will be a good review for you. And I do apologize, guys, if you have some other questions, but this will be the last question I'm going to cover, at least for the stream. So, because I wasn't planning on going late, I was going to I'm going to do an early stream. I'm tired. And then here I am, spawning 50 minutes, but whatever. Dang. Okay, either way. So first thing, if you want to complete the square, write this in standard form to vertex form. You need to factor out a 2. So therefore, you have a quadratic where a is equal to 1. Then we want to create a perfect square trinomial. So we're going to complete the square. So To do that, we can do is take our b, which is our 2, divide it by 2, and then square it. So we do b divided by 2, square it. I have an easier way of thinking of that, but in this case, when I do 2 divided by 2 is 1, 1 squared is 1. Now again, you can't just add a 1 without subtracting a 1, right? If you're going to add a 1 on one side, then you also have to make sure you subtract the 1, right? Because remember, this is an equation. But now what happens is when I added that 1, that created a perfect square trinomial. So when you take b divided by 2 squared and you add it inside the parentheses, that creates a perfect square trinomial that can now be factored down into 2x plus 1 minus 2. And just a nice thing is once you get like kind of efficient with completing the square, it's very nice, obviously, when you have nice numbers. When you don't have nice numbers, that's why this is a very helpful formula to kind of remember for the axis of symmetry in the vertex. But here, without doing any math, I can also find the vertex very easily, -2 or -1, -2. And that is going to be my vertex for that problem. So there you go, ladies and gentlemen. That is kind of it. We covered a lot through this live stream. We talked about completing the square to find the vertex, just a good old distributive property, graphing, graphing quadratics, covering the asymptotes, and law of sines, law of cosines. Then we went back into talking about the discriminant, finding the zeros or dividing polynomials, and then factoring when a is not equal 1. So again, guys, I really do appreciate you joining for the live stream, as well as for those of you guys that are helping each other out, asking questions, as well as helping some other people. I will plan to be back again for our next week live stream, week 11. Again, if you guys do have questions coming up, if you're not on spring break and you have some questions, please feel free to submit those on the community tab when I post it on Saturday, and I'll look forward to answering your questions next week. All right, guys, have a great night. Cheers.